Okay, so this video is going to go over question 4 from the notes on bearings. As we read through the problem, the first thing that we notice is Kevin is biking 4 kilometers in the direction 65 degrees east of south. So I'm going to start by making my compass, and I want to go 65 degrees towards the east from the south direction. So 65 degrees would be this measure right here. And we know that he is headed a little longer, 4 kilometers in that direction. So from this point to this point, let's say, is 4 kilometers. Then he's changing course. So again, I'm going to draw another compass. And from here, we want to go 25 degrees east of north. So 25 would be this measure. And this is a length of 3 kilometers. Our end goal is to figure out from this ending point to the beginning, what is that length? So we'll call this length x. And what is the bearing? Call that theta from the starting point to the ending point. So we want to start by adding some information to the diagram. First and foremost, I know that this angle, which is not necessarily the total angle here, but from the 65-degree mark up to this dashed east line would be 25. They're complementary angles. And then also using the 65, I can fill in using alternate interior that this angle would be 65 as well, which is actually great for us because 65 and 25, just like above, makes a 90-degree angle. So the first thing you would get out of this problem is that this is a right triangle. So actually the distance, we don't even have to do any work to find it because this is a 3, 4, 5 triangle. Since the triangle is a right triangle and the two legs are 3 and 4. Now, to find the bearing, we do have to do a little bit of work. So in this case, depending on how your sketch ended up, I know mine's kind of close to that east line over at the starting point. We have to be careful. So I'm actually going to solve and find this angle over here. I'm going to call this point B, and I'm going to solve to find angle B. So opposite of angle B is the 4, adjacent to it is a 3, so that means we're looking at tangent of B equals 4/3. So angle B would be 53.13 degrees. Now what that then gets me is complementary to that is this angle over here. I called it alpha because there's a lot going on at this point, so I didn't want to put an A there. So alpha would be 90 minus 53.3 or 0.13 or 36.87. And then there's a couple ways to solve for theta from here. You can kind of do a big angle addition where you say that theta plus the 36.87 plus the 65 degrees, all three of those together are going to build 180 degrees because they go from north to south. So that's one option. You could also take, kind of as a side note, you could take alpha, which was 36.87 minus 25, and get 11.87. And then 11, the complement of 11.87 would be theta as well, because from theta to the green east line that I have drawn there would be a 90-degree angle. Either way that you slice it, we should find that theta solves as 78.13 degrees. So as we write that as a bearing, since they use the surveying or the ship navigation type, we are headed to get from the original point to point B that I drew in. We are headed towards the north, but we want to go 78.13 degrees to the east. So if you just wanted to go, maybe you were back at Kevin's house and you wanted to go meet Kevin, you would have to head 5 kilometers at the bearing 78.13 degrees east of north.